Good evening, everyone. Welcome to a quick tutorial on this induction proof um, from Matt Eichhorn's textbook for CS 2800 at Cornell University. So yeah, let's get started. In any undirected graph, G is equal to V comma E. The sum of the degrees in the graph over all the vertices is equal to 2 times the edges. So a degree in a graph, let's say we have U and we have V. A degree in a graph is the amount of edges that are incident to any vertex. So, for example, if I draw an edge here, U's degree is exactly 1 because it has one edge incident to itself, and V's degree is also 1 because it only has one edge incident to itself. So, let's get started with the actual proof. So, we want to show P of n where we induct on the edge set, the size of the edges. So we will show that for any undirected graph, G, V comma E, the sum of V and V, degree of V is equal to 2E. Okay. Where the size of E is equal to N. So let's get into the base case. This is what allows us to even try to prove it by induction. So we know that E is going to equal to 0 because we're proving P of 0, where the edges are 0, right? So the sum of the vertices, or the sum of degrees in the graph, rather, is going to equal to 0 because this is exactly this example where we had U, V, anyone else, R, so on and so forth. If there are 0 edges, then nobody has a degree. So we can safely say that 0 is equal to 2 times 0, where 0 is edges, and we're just directly copying from this here, and that will give us 0, and this is true. So the base case is done. For the inductive hypothesis, assume for k, so this is P of k, assume for k in natural numbers that a graph with E is equal to k edges satisfies the proposition above. Yep. Okay, so the inductive step. This is the tricky part, but it's not that bad. So, let's say we have a graph G, and G has its size of its edge set is equal to k plus 1 edges. Okay? So notice how it's 1 larger than the inductive hypothesis graph. That's going to come in handy. So in this graph, we know that it has at least 1 edge, right? Because we added 1. It has k plus 1 edges, and we said that k is greater than or equal to 0, right? So let E is equal to U comma V, and this is just edge notation for saying that the edge is shared by U and V. V in G. Okay? Let's remove it. This creates G prime. Okay. And we know from our inductive hypothesis, because G prime has E edges, because we took one out, that this thing from above is exactly true. So we can copy it down. Okay. Now, when we add back E is equal to U comma V, we know that exactly in this example where there are U and V, when we add this back, this edge, U gains a degree. V gains a degree. So on both sides of this equation here, we can add 2 because the degrees are now greater than they were before. So this is going to equal to 2k plus 2. And then using a bit of algebra, we can see that this is the same as 2k plus 1, and that's just doing the opposite of distribution, right? And k plus 1 is exactly E edges in the graph G. So that's it. We've shown the proof to be finished by the principles of induction. We have shown the proof.